This is passage 5. It's a conflicts passage. This is probably the most time-consuming passage. It's a reading-heavy passage. It's the only one you have to spend more time in the passage on. This is a conflicts passage, so a DRC approach. Conflicts, carefully read. It's the only passage you really have to read all the way through. You have two things you're looking for. The first is to identify the conflict, and the second are the different approaches to the conflict. Often helps to write or draw pictures as you go through. So probably 2 to 3 minutes on the text before you get to the questions. There's only one conflicts passage per test, and we know it's conflicts because it says student 1, student 2. It's usually going to say student or scientist, maybe hypothesis or method. So the conflict itself is generally going to be in this area, the last paragraph of the intro, and then you want to identify the differences by looking at the different students or scientists' hypotheses. Your step 1 should be to identify the conflict, which is usually in the last paragraph of the introduction. So this first part you can skim, you don't have to read carefully, but really pay attention to this last part, because that's where you're going to find the conflict. 2 students discuss the evolution of the algal system. So then you're going to read, well, what is the algal system? We have algal A, a 3.6 solar mass Ilmes star. It tells you up in step 1 what an Ilmes star is, in case you need to find it. Algal B, a 0.8 solar mass post-Ilmes star. Again, in step 1, it mentions post-Ilmes. And algal C, a 1.7 solar mass star. It tells you what 1 solar mass is, the sun's mass. The next one, the 3 stars orbit a mutual center of mass with algal B, A and B closer to each other and to the center mass than algal C. So you want to draw that as best you can, so you have a decent understanding of what's going on. So that's the current situation. So step 2 is to identify the differences, and sometimes it helps to draw pictures, at least it does for me. So the 3 stars formed at the same time around the same cloud of dust. Algal B originally was the most massive, so I just wrote most massive. You could just write big. Because the matter in the outer parts of B was more strongly attracted to A, the matter flowed from B to A over time. So A stole from B, flow made A bigger. Then student 2, algal B was not part of the original system, algal A and C, so they're the original. Algal B and A formed in different clouds of dust, 2 different but intersecting orbits. During a particular orbit, they encountered each other and became part of the system. B never lost mass to A. So you get the basic idea. The difference is student 1, they all formed together around the same dust, and B lost mass to A. Student 2, A and B formed separately, but they collided, and then one star never lost mass to another star. Our approach to the questions is the R&R approach. So you're going to read the question and then reread the question. So in your first reading, you're just trying to understand what it's asking, kind of orienting yourself, skimming, if you will. And then your reread, you're really breaking it down step by step. So as we go through it, I'm going to be doing the reread part. Already read it. Hopefully you've already read it, and we're rereading. If you haven't read it before we start, pause the video and read it before we start. Now we're ready for the questions based on student 1's discussion. So find student 1, put your finger on it, and fact 4. So fact 4 says an Ilmes star becomes a post star when the star expands in volume and produces the majority of its energy by fusing hydrogen to helium in a shell surrounding its center. While matter flowed between A and B, algal B produced the majority of its energy by fusing hydrogen to make helium in a shell surrounding its center. That's directly from fact 4. So pretty easy to understand. It's just a point and find in this one. Suppose if Y question is number 26. Suppose the chemical composition is uniform among stars formed from the same cloud of gas and dust, but varies among stars formed from different clouds. Student 2 would most likely agree with which of the following statements comparing the chemical compositions of stars in present day. So student 2, we remember, says they formed in separate clouds of dust. So they're going to say that B would be different from A and C. So A and C are together, B is different. So A and C had the most similar compositions, choice G. If the mass of the sun, suppose if Y, you're going to have to think, is 2.0 times 10 to the 30th, what is the mass of algal C? So we know 1 solar mass equals the sun's mass. So algal C is 1.7 solar mass. So it's 1.7 times bigger than the sun. Well, we can notice this 10 to the 30th doesn't change. So we're going to just ignore it. So it's going to be 2 times 1.7, which is 3.4. All right, so times 1 plus a little more, so 3.4. So your answer should be C. Question number 28, there's a little bit of knowledge needed for this question. Which of the following statements best explains why the reaction described in fact 3 requires high temperature and pressure? So suppose if Y means you're going to have to think a bit. So fact 3, put your finger on it, find it. Pre-M star becomes an MS star when the star produces the majority of its energy by fusing hydrogen nuclei, protons, at its center to make helium nuclei. Let's go ahead and eliminate choice H and J, because H and J say electrons. Protons are produced according to fact 3, so easy elimination. So if nothing else, you get rid of those two. Now you need the knowledge. Protons are positively charged and like charges attract. Protons are positively charged and like charges repel. So it doesn't matter how they're charged. Do like charges attract or repel? Opposites attract. So like charges repel. So the answer is G. Based on fact 5, so fact 5, the more massive a star, the more rapidly the star passes through each of the 3 stages of its evolution. And student 1's discussion, so put your finger on your student 1 discussion, which of the 3 stars, if any, was most likely to become an MS star first? So we know that B was originally the most massive, so therefore B had to become, went through the stages the fastest. Based on fact 5, would student 2 agree that by the time algal A, so A is the 3.6, stops being an MS star, algal B will have spent as much time being an MS star as algal B. So A will spend as much time being a star as B. So we know from the reading that the B was not part of the system. What's more key is this statement down at the bottom. B was always less massive than A. Okay, so B was always smaller. Student 1, remember, said that B was bigger and lost mass. Student 2 says B was always smaller. In fact, 5 says the more rapidly the star passes through each of the 3 stages, the more quickly its evolution. So it would not, algal A will not have spent as much time as B, because the more massive, the faster it goes. Even if you didn't see that, didn't rationalize the answer, you could say that A has always been less than B, as it states in choice F, is wrong, because that's not what it says in the reading, right? B was always less massive than A is what it says. We know that one's wrong. So F is wrong for that reason. J is also wrong. A has always been less massive than B. That goes against the reading. So you can eliminate F and J just because that's not what it says. Then you're just left deciding, well, is it yes or no? Okay, and that depends on understanding fact 5.